so you're safe. But when I always like to see if I can factor. Can I factor anything out of a 12, a 24, and a 9? It's a textbook problem, so I'm expecting I could factor this. I could be wrong. I think I can. Kevin, I don't know if you're okay at factoring these case 2 trinomials. They're not as bad as you think. If you hate what I'm about to do, you can use your graphing solver to just solve that thing, like I showed you in class before. You can do it. You know, graph it, find the intersect. But I'm thinking I need 2 numbers I have to multiply to 4. How about a 2 and a 2? I need 2 numbers to multiply to a 3. How about a 3 and a 1, right?
Mhm.
Alright, if I put a 3 here and a 1 there, that's 6, that's 2, what's the difference? Does it work? Alright. Let me try another option.
Oh wait, isn't it minus 8x?
What was that?
Yeah.
It'd be 2 minuses, and you have 2x and 2x, and one would be a 3 and a 1, right? But it wouldn't come up to that 6, would it?
Shouldn't that be an 8?
Yeah, that's why. I was like, you know what's funny? Thank you for seeing that. This is a what? Now, I was about to say, I was shocked. Because when I didn't work this problem yet, I'm like, oh my gosh, I can't believe the author gave a problem where you actually had to use the what? Quadratic product. I thought it'd be factorable, and it is. 2x, 2x, multiplies to 3. You see that?
Mhm.
Isn't that factor? Keep in mind now, some of you use the graphing solver to graph to some of you do quadratic formula, right? So, I've got 2 answers. Please ignore that, everyone. 3 doesn't have a variable. What's my 2 answers? X equals what?
Half and 3 halves.
There's 2 answers problem? Nah, one of them's out of the domain. We're gonna have to toss it. You're gonna figure it out. Which one of those do I toss? Because, you ready? It's not in the domain. You know what I mean by domain? In the real life problem, this cardboard originally was how long? 3 by 3. One of these, if you cut them out on both sides, I don't think you got a box left over. Go back, look at it. Which one of those do I have to toss? Remember, the original side was 3 feet by 3 feet. Right?
Can't you plug it on that?
Oh, the 3 by 3 half. You cannot ever.
What do you all think?
3
I
half.
can't use that. That's 1.5, right?
Mhm.
Think about it. And we check it out. If you cut 1.5 from this side, and 1.5 from that side, what's 3 minus 1.5 minus 1.5? You got how much left? Nothing left, so we toss it. So there's the answer. Is it the answer to the whole question? Well, that's the dimension, but now the easy part. They said find the dimensions that give the maximum, alright. Find the dimensions that maximize volume. Okay, here it comes. Well, that's 1/2. How do I get the length?
3 minus 2 times half.
What's 3 minus 2 times a half?
That's 1.
And what's 3 minus 2 times a half?
1.
3 minus 2 times a half would be, is that 2? Or
Oh, yeah, sorry, 2. I'm sorry.
Yep. So what I'm saying, if we plug in these 1s in here, we get 2 and 2. If this stuff is feet, you can say 1/2 by 2 feet by 2 feet. What were the dimensions, number 12? They were feet. And when 1/2 foot by 2/2 foot by 2 foot by 2 foot, hey, I'm curious, what's the volume? It'll be cubic feet?
Yeah. Feet cubed.
I like this stuff. That's why I like teaching the calc 3 with optimization. You do this 3-dimensional. Sometimes it's a sphere, or sometimes it's a cylinder. Yeah, but these are 3-dimensional. That's 3-dimensional, right? But in calculus 3, it's multivariable. You deal with multivariable. You can get everything into two functions, 2 variables, and there's ways to do that. Everyone care about that? Hey, let's do one more. We won't finish optimization tonight because I want to make sure we see every scenario. But let's do another one. distance. Now, the hardest part here, I said you gotta know what? Area of a circle. What is it? Okay. I said you need to know area of a rectangle, what's that?
Length times width.
And I said you need to know volume of a box.
Length times width times height.
I do have one more. Make sure you know distance between 2 points. It's got a gigantic radical. Come on, Amber, I'd love to hear you roll it out for me.
Isn't it like square root yeah, x squared minus.
Gosh, you already know it, I'm so proud of y'all.
And then it's like y squared minus.
Hey, those you going to calculus tree, do you know what this formula turns into? When you're three-dimensional? They just put a plus in what letter?
I,
For the
Z,
z-axis,
Z,
and it'll be a what? z2 minus z1 squared?
uh-huh.
Do y'all follow me? I know. You go, oh, okay. So nothing scary about when you hear I think you'll love calculus 3. Just you get, oh, distance between space from here to here, rather than just on this one board here. All right, so what do we got here? I was looking at this morning, and when I saw 2 problems that dealt with distance. One was straight lines. I'm like, all right, we've done no straight lines. I thought we'd do one with it's got this little hyperbola thing in here. Or not a hyperbola, I'm sorry, like an ellipse. So when I'm in 4.7, and what is this one with the ellipse? Everyone? This is like number 21. I don't want to do number 21 because you can practice it, okay? So I'm going to change it up a tab. And here it is. X squared. Last problem. Plus y squared. Is 16. Alright, and when you gotta find the points, on 16x squared plus y squared equals 16 that are furthest away from the point 1, 0. Now that function, it's not even a function, I'm sorry. I apologize. That equation looks scary. That's not a circle, is it? No worries, everyone. I don't even care how far you got in pre-calc. That's not a circle, that thing's called an ellipse. See, a circle would have been this. That's a perfect circle. What would be the radius of that circle? 4.
4, yeah.
Well, this is more like an oval. When you got like a coefficient off one of these things and there's a plus between them, it just gets egg-shaped, right? They call it an ellipse. And then you go, I remember when I was I used to stress about having to sketch these, like, oh, it looks so hard. I finally realized these are the easiest to sketch. Just use the intercepts, okay? So can we find some intercepts real quick and make a sketch? Ready? Let's make a sketch of this guy. Put it right up here. Let x equal 0. Boom, you're gone. Who could tell me the 2 y values?
Plus or minus 4.
Plus or minus 4. So I'm going to sketch this. All right. So if x is 0, plus or minus 4. Now I need 2 other points. Piece of cake. Let y equal 0. What would x equal?
Plus or minus 1.
Plus or minus 1. Okay? Do you see that? Sarah, do you see this? It's called the intercept method. I'm just trying to make this sketch. And you go, oh my god, things me crazy. All I'm going to do is let y equal 0. So that's 0, that's gone. If I solve for x, 16x squared equals 16. So x squared would equal 1.
Yeah.
So x would equal plus or minus the square root of what? 1.
Oh, 1.
Does that make sense?
Yeah.
Because it'll look like this, look. And then you divide the 16, you get that plus or minus a 1. So, everyone okay? Let's sketch that. Where would it be? Alright. -1, 1. This is up at what? 4 and this is down where?
No.
4. Does everyone see the egg shape, the oval, the ellipse?
Mm-hmm.
Now, what do we gotta find in this image?
Point.
Find the points, it says plural, that are furthest away from 1, 0. Where's 1, 0? Right here?
Mm-hmm.
So can we guesstimate before we start where the points would be? Just what would it has to be on that curve to be furthest away. I don't think it would be straight across. That's short.
Should be the,
On your right hand side.
Maybe up in these corners. Is that what I agree?
Mm-hmm.
That's always great. Well, that's a great skill to get an idea of what the answer should be. It looks like the 2 points should be, one should be like up here somewhere. It would be very far, and then down here. Looks like there's 2 answers. It's the same x value. Alright. So what are we trying to optimize? Think about it. Area? Nope. Volume? Nope.
Distance.
Yes. And then this is what's tough on a test. They never said the word distance, did they? Do you follow me? So just be ready for that. You go, oh, I've got this distance from in my back pocket, just in case. But they never said just
so if it's
maximize distance. They go, find the points on here that are furthest away from this. But we're really trying to maximize the distance, right? The distance between points. So we need that. Does that make sense, Amber? So I'm going to start with what? A big D. All right. X2 minus x1 squared plus y2 minus y1 squared. Distance from what point?
1, 0.
I want to put the 1, 0 in there. This is looking better already. Loving this. So far so good?
Mm-hmm.
Yeah? Okay. Can you make that even better?
Yeah. So x
What's
square-
y minus 0 squared?
Just
y
y
square.
squared.
Yeah. So first I did,
Mm-hmm.
but I still have a sad face. Because, I've said this a couple times, and here we go again, optimization is such a fun section, except for one thing. Before you optimize,
Yeah.
before you differentiate
You have to have one variable.
one variable, and I still have M in. So I'm gonna let you all look with your eyes.
You can plug in the one,
Amber sees it. Is there
The y
something I can put instead of that stupid y
Yes,
squared?
16,
Bug me.
16 minus 16x squared.
Ah, you guys are great. You're looking at this thing, and you're like, just isolate the what? Here, what would y squared equal? 16 minus what?
16
X
minus
squared.
16x.
Come on over. Smiley face. All right. I like this. Now I got x minus 1 squared plus 16 minus 16x squared. Now, Kel, be careful. Don't square that. That would drive you crazy on the test if you went and squared this, because then you'd have to FOIL that. That's equal to that, isn't it? That's what I mean. So it's nice and neat. Now, I think it'd be good if we expand this and get this to look a little better on the radical. Do you agree?
Mm-hmm.
Okay. What's that expanded?
X square minus twice x plus 1 plus 16 minus 16x squared.
All right. Any like terms in here?
X square and 16.
Aren't good. What's that? Negative.
So negative 15x squared.
Minus 2x?
Yep.
Plus what?
17.
And then if I'm about to differentiate, maybe I should write it like all this to the what? Just so everyone's comfortable with that. So far so good?
Mm-hmm.
I think it's time. How do we optimize? Do I set that equal to 0? Nope. What do you set equal to 0? And somebody might be like, oh, this is going to be a crazy derivative. Oh, no, it isn't. The hard part's done. You finished the hard part right there when you saw that, Amber. The rest was smooth sailing. We can differentiate that. The half comes where?
In the front.
All right, put your dash, look deep front. 1/2. Decrease all this by what? But don't forget what?
Chain.
Yep, chain.
So it
What's the
will-
derivative?
minus 30x minus 2.
Love it. And when we're chain rule, now you're gonna multiply what? Negative 30x minus what? Amber, did you see that?
Let's see what the negative, oh, okay, Yeah.
Cha-chain, right?
negative.
Yeah, let's write this again. This looks kinda weird. Cause I'm gonna set this equal to 0 and solve it. I've got a fraction, it looks like.
Why do you set it, okay,
My,
yeah.
in optimization, we always set the first derivative equal to 0. You might say, or where it does not exist, but,
So doesn't it become like,
that's a 2. This goes back with a radical where? And what's up in the numerator?
Minus 30x minus 2.
Usually with optimization, there's only one possible answer when you get to the end, so you don't have to even check stuff. Good news, everyone. Should I check that denominator? I'm gonna tell you why you ignore it. Because doesn't that represent the distance,
Mhm.
right? Didn't that come from distance? So if you set this equal to 0, you're saying the distance would be what? 0. No, we're looking for a maximum distance. So ignore this part. What's the only part you gotta solve equal to 0?
negative 30x minus
And I think you all can do that. Let me box all this off. Josephine, I wanna be clear why we're not worrying about this. That's actually the same formula as the distance we had earlier. That would mean distance would be 0. And it's not 0. I'm just gonna come up here. And get 30x minus 2 equals 0. How do I solve that?
Add. And the y negative
15.
You got it. Boy, it's small, but it's actually got a negative